Assalamu alaikum. In this lecture, we will solve the following example. Simply, we have a 220 volt, 500 ampere, 600 RPM separately excited DC motor, which has the armature resistance equal 0.02 ohm, and the field resistance is equal to 10 ohms. The motor is drive a load of TL equal 2000 minus 2 n Newton meter, where n is the speed in RPM. If we ignore the rotational losses, and we are assuming that we are using two DC-DC converters, one to control the armature and one to control the field, with a supply voltage of 220 volt, and switching frequency is equal to 1 kilohertz. We need to find the duty cycles of the converters at n equal 450 RPM, and also we need to find the duty cycles of the converters at n equal 750 RPM. So simply here, the first speed is below the rated speed, and the second speed is above the rated speed. So let's try solve the first part. For the first part here, if we calculate TL at n equal 450, so this will equal, TL is given here, so this will equal 2000 minus 2 multiplied by 450. If we do the math, this will equal 1100 in Newton meter. Now simply, if we calculated the rated torque, we can calculate the rated torque as follow. We know that VA is equal to EA plus IA RA. So from here, we can calculate EA, which will equal 220 minus 500 multiplied by 0.02. If we do the math, this is the 210 volt. So here I'm calculating this is at rated condition. So we can calculate because TE, because we are ignoring the rotational losses. This means that TE is equal the torque developed, and we know that the developed torque is equal the power developed over omega m, and this will equal EA IA over omega m. So here TE will equal the power developed at rated condition over the speed at the rated condition. So this one is EA IA over omega m. So EA 210 multiplied by IA at rated condition, which is the 500, over the speed, which is 600, converted now to rad per second, so it's pi over 30. And if we do the math, this will equal to 1671. So now if we compare the rated torque to the load torque at n equal to 450, we can see we don't need to go to the field weakening at this case. So this means that we are in the armature voltage control. So this case is controlled by armature voltage control, in which the field voltage should be the rated voltage. So here is controlled using armature voltage control. So what information we can get here? Automatically we can get here that VF should be VF rated, which is the 220. So from here we can calculate the DF, which will equal 1. So we get the first duty cycle for the converter, for the DV converter, which equal to 1, which correspond to what? To the rated field voltage. So now we can calculate the current. We know that because here the flux is constant, then the torque will be proportional with the current. So this means that T1 is proportional with I1, and T2 is proportional with I2. So simply from here we can calculate the current at n equal 450. So simply we can say that IA2 will equal IA1 multiplied by T2 over T1, where 1 stands for the rated condition and 2 stand for the n equal 450. So this would be IA is 500 multiplied by the torque, the second torque, which is the 1100 over the rated torque 1671. If we do the math, this will equal to 329 ampere. So also we need to, if we need to find VA, we need EA also. The same thing, because the flux is constant, we know that EA is proportional with omega. So simply here we can write in the same scenario that E2 will equal to omega 2 over omega 1 E1, and this will equal N2 over N1 E1, and this will equal the N2 is 450 over the N1, the rated speed is 600, multiplied by the rated back EMF, which is the 210. If we do the math, this will equal to 157.5 volt. So now we can calculate VA, which will equal to EA plus IA RA. So this will equal EA, we already found 157.5 plus IA, we already found it here, 329 multiplied by 0.02, and this will equal to 164 volt. So now if we need to calculate the duty for the armature, dA is equal to the out voltage 164 over the input voltage 220, and this will equal 0.7455. So this is actually the first part. So what about the second part? For the second part, we can notice here that the speed is above the rated speed. So this means that for this part we need to do the field control. If we're doing the field control, this means that VA must be VA rated, and this will give us a very good information that we can calculate dA, which is equal to 1. Why? Because I need to impose the rated voltage to the armature. So simply which is 220. So this means that for the second part I can get dA with no time, from the understanding that we need to go to the field weakening control. So the voltage to the armature must be the rated, so dA is equal to the rated. So let's try solving the second part. So at n equal 750 RPM, which is greater than n rated, so this means that we need to do the field control. Doing the field control meaning that VA must be VA rated, which is the 220. So here, as we said, that we get dA with no time, which is the 1. Now let's calculate TL at this case, which equal 2000 minus 2 multiplied by the n 750, and this will equal to 500 Newton meter. Now we know that T is proportional with the flux and IA. So in this case we can say that T is equal K2 phi 2 IA2, because 1 is already occupied for the, let's say, for the rated condition. So here we can also write T2. So from here we can get, let's say, first relation between the torque and the current. Now we need to calculate K phi at the rated condition. So at the rated condition, we know that EA1 is equal K1 phi 1 omega 1. So from here we can calculate K1 phi 1 to be EA1 over omega 1. So if we do the math, this is the 210 we already calculate. The rated was 600. Don't forget to convert it to rad per second. So this is the pi over 30, or you can say 2 pi over 60, and this will be the 3.342. This is volt second per rad. Now at n equal 750, we can calculate the omega 2, which will equal 750 multiplied by pi over 30, and this will equal 78.54 rad per second. So now if we go to the voltage equation, which say that VA is equal to so let's assume this is VA2, EA2 plus RA IA2. Now EA2 will equal K2 phi 2 multiplied by omega 2 plus RA is already given 0.02 multiplied by IA2. Now this one, because we are using field control, this already is fixed at the rated value, so 220. So now we will have that 220 will equal to K2 phi 2 omega 2, already we calculated here, so this will be multiplied by 78.54 plus 0.02 IA2. So this is equation with two unknown. In order to solve it, we need another equation. This is the second equation that we are looking for. So from here we can write K2 phi 2 will equal to TL T2 over IA2, which will equal to 500 over IA2. If we plug this relation here, we will get 220 will equal to 500 multiplied by 78.54 over IA2 plus 0.02 IA2. If we rearrange this equation, we will get 0.02 IA2 square minus 220 IA2 plus 39270 equal to 0, which is a second order algebraic equation. If we solve it, we will get two solutions. The first one is IA2, which equal to 181.5 ampere, and the second one IA2, which will equal to 21647 ampere. Now which one we will choose? And now if we compare, this is below the rated, this is much higher than the rated. So the first indication that you will select the first one, or if you need to do more engineering sense and investigation, if we calculate the efficiency, remember that the efficiency will equal to P out over Pn, and P out is the torque multiplied by the omega, and Vn is Va Ia. So for the second one, let's calculate only for the second one. For the second one, the torque is 500, the speed is 78, point something, 78.54, over the voltage is 220 multiplied by this current IA2. If we do the math, then the efficiency almost equal to 0. So this means that this solution is not acceptable or not visible. So this is the solution that you will take. If you calculate the efficiency, it will be around 0.98. So now we also have the current here. So if we have the current, we can calculate the K2 phi 2 here. So K2 phi 2 will equal to the torque 500 over the current, which is the 181.5. If we do the math, this will equal 2.755. Now we know that that the flux is proportional with the field current, and we know that the field current is proportional with the voltage imposed to the field circuit. So this means that VF1 is proportional with K1 phi 1, and VF2 is proportional with K2 phi 2. Now we have K1 phi 1, we already calculated here from the rated condition, and K2 phi 2 we already find it here, and at the rated condition we have the voltage, which is the 220. So from here we can calculate the feed voltage at N equal to 750. So here VF2 will equal to K2 phi 2 over K1 phi 1 multiplied by the rated field. If we do the math, this will equal 181.36. Now we can calculate dF with no time, which will equal 181.36 over 220, and this will equal to 0.82. So this is the example and how we can solve it. We discuss how we can distinguish between the armature voltage control, the feed control, when we need to switch from the armature voltage control to the feed control. That in the field control, the armature voltage will be the rated, and in the armature control, the field will be the rated. So I hope this example will help you. Thank you for listening. Assalamu alaikum.